And similarly, you can find the length of the side opposite angle gamma. So C is equal to B times sine gamma over sine beta. So I have the 4.2 sine 16 degrees and over the sine 121 degrees, and then you simplify, you have the 1.35, and then in this way you find the length of the other two sides. Now let's look at the case 2, the most difficult case, the ambiguous case. So it's the SSA, and this A here is a non-included angle. So, and let's first look at the subcase 1, in which the angle alpha, the known angle alpha, is an acute angle. Okay. And we need to compare. Suppose we know the angle alpha, we know the length A and length B. So right now, angle alpha is known, and also A and B are also known. Okay, this is for the A, and this is for the B, and this is for the alpha. Now we need to compare A, B, and the length of an attitude. So let's first draw the sketch. The case 1 is like this. So this is the angle alpha, and this is length B, and then this is length A. So we need to compare the A and B first. So in this case, this let me use the A for the vertex of the angle alpha. Let me use a C for the vertex of this angle, and then we can draw an attitude from the C to this bottom line, and we use H for the length of this attitude. Okay. So now we first compare A with this H. So in this case, A is less than H. Then you can see, if you use the C as the center of a circle and use A as a radius, and you use a compass to draw a circle, then you would have the circle, part of the circle like this, right? And the circle does not touch this bottom line. So that means, in this case, these two sides and this angle cannot be part of a triangle. You cannot form a triangle because this side does not touch the third side, right? Only when this side touches the third side, in a non-trivial position, you can form a triangle. But right now, this A is less than this H. If you use the C as the center of a circle and A as the radius of this circle, then the circle does not touch this bottom line. So in no way you can form a triangle. So in this case 1, just no triangle. Now let's look at the case 2. And this time, suppose you have the A exactly equal to this H. So let me copy this sketch here. And this is your H. And this H exactly equal to A. So this is your angle alpha, and this is the A, and this is the C. So in this case, you can have exactly one triangle, because this is only point that this side A touch this bottom line. And in this case, you can form a right triangle. So if the length A is equal to the length of this attitude, then you have the one right triangle. So this is case 2. And case 1 and case 2 are all simple. Now let's look at the case 3. Case 3 is just the ambiguous case. So case 3, and in this case, we have the A, this length, bigger than H, but less than the B. So we have the A bigger than H and less than B. Now let's look at the possible cases. So we draw the sketch. So this is the attitude. And this is your A. And if you use the C as the center and A as radius to draw a circle, then the circle will touch this bottom line at 2 places. One is here. Let me call this B. Another point is here. Let me use another color. And let me call this B prime. So actually, if you use the C as center and the A as radius, you draw a circle, and the circle will touch this bottom line at these 2 points. It's like this, okay? Because here this A is bigger than this H. Okay, this guy is H, right? But less than this. Okay, side B. Less than B. So in this case, this circle touches this bottom line at 2 places. So that means you can have the 2 triangles. One is triangle AC B prime or AB prime C. or you have another triangle ABC. Okay, so two triangles. And this happens in the case that the A is greater than H but less than B. So this is the most difficult and ambiguous case. Okay, so this is the first subcase when this alpha is an acute angle.